Hey everyone. Thank you so much for joining us for the AKS Automatic virtual launch. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links. Our session is being recorded. It will be available to view on demand right here on our channel. With that, I'd love to turn it over to our host for today. Let's start the show.
Good morning. Thank you, Anna. Good afternoon, maybe good evening for some of our viewers who are big keeners. And welcome to the global virtual launch of AKS Automatic. We're super thrilled to have you join us today as we take a deep dive into how we are simplifying cloud native infrastructure at Azure. Kubernetes has long been a powerful but complex tool. With AKS Automatic, we're changing that, and we're making it easier than ever to tap into the power of Kubernetes on Azure and meet the needs of all teams developing applications for this modern era of AI. Today's event is packed with insights. You'll hear from industry and product leaders, see live demos, and get a first look at how AKS Automatic is redefining Kubernetes for developers and platform teams. We also have a super fun keynote lined up for you that will involve some live sketching. So I am personally very excited for that one. Let's dive in and explore how this new experience accelerates innovation across organizations of all sizes. Now let's get to the good speakers, hey? I am delighted to introduce our first keynote speaker. Priyanka is a best-selling author, educator, advisor, board member, and she leads our developer advisors team here at Microsoft Azure. You might know her better, though, as the Cloud Girl. Please welcome Priyanka Vergadia to the virtual stage.
Hello, everyone. I'm so excited to be here and so excited. I've got two streams going, so I'm going to cancel this one. Sorry. All right. I think we're good now. So I'm so excited to be here. Thank you, Corey, for such an amazing introduction. And today what I've planned for us is really walking through where we are with AI, native AI development, and how we can get to the actual state of productivity with AI for all of our products and for all of our ideas. And so let's start by zooming out of this chart that I tried to build to give you all the information that I am hearing and I am seeing from anything that I'm reading, to talking to customers, to all different types of researchers. And I've kind of tried to summarize that for us in the next 15, 20 minutes to kind of make decisions on what we need to do to create amazing applications with AI. Okay, so with that, here is what I thought would be a good sort of a narrative for thinking about AI. So the first things first, right? On the pink right here, how AI agents are transforming businesses. We are definitely making a lot of progress in how we've since 2022, right? There's lots of new use cases we've identified, uncovered in businesses. We'll look through that and how some of those are really the lowest hanging fruits that we can start off with. Then we will start talking about state of AI adoption, where we are at with adopting AI in those use cases and what the researchers are telling us. Then we will look at how to fully realize AI's value. And this is where we start to get technical and start to understand the architecture and the components that we use. And then the way we build AI agents and how it has changed since 2022. There's a lot that is evolving, the models are evolving, the infrastructure is evolving. So we'll talk a little bit about what's changing, and then the last thing we will do is I did there. Really get into how do we build AI agents and applications, and this is really getting technical at this point in the details of the architectures. Now, again, I'm not like we've got only 20 minutes. I'm not going to go super technical, but I'll give you enough to sort of noodle on, think through, and what types of tools to start thinking about and look at. Okay, so with that, let's get started with how AI agents are transforming businesses. Now, there's lots of ways to think about this, but I sort of got it into two categories. There's industry use cases, and then there is functional use cases in any company. So when you talk about industry use cases, there's definitely things you can do in education, where we're seeing bots being used for both students and teachers, in healthcare for patient care, and also optimizing the doctor's life, the retail, where we are all experiencing it with recommendations and personalized recommendations, in finance, with helping, whether it's in insurance or helping claims, or it's even just in a bank with virtual tellers, and manufacturing, in building better products, right? And then on the right hand side with the functions, any industry, any company, any enterprise can start thinking about AI in definitely the lowest hanging fruit, which is the customer service and customer support. You can make your lowest, easiest questions definitely automated for 24/7. That is the lowest hanging fruit that anybody can start off with. And we've got the tools pretty mature in this area as well. So that, and then start thinking about sales and marketing. Definitely marketing is getting so much love with content generation, and customizing with your own brand voice. All the tools are available to do this today. Finance and business operations, supply chain, and then HR, right? All of these categories of functions are being transformed with AI. And if you're not currently doing this, we definitely have lots of links, lots of places where you can start with. You can drop those in the comments as well. And please do ask questions as we're going through it, and we'll answer them. Now, next thing I want to look at is state of AI adoption. Now, where are we, right? We're all talking about AI. Enterprises are all thinking about AI, but really, where are we? And this is the scope of where we've gotten. In the next 3 years, by 2028, we will have about 1.3 billion AI agents. That is a large number of AI agents. This is IDC's report that projects this number. 3 years is not far. And if you just look at by the end of this year, 60% will use AI agents for specific business functions, these functions that we just talked about in the previous few minutes, right? If your company is not doing that today, you should be doing that today if you're the one making the decisions. And if you're the one helping make the decisions, then these are some of the use cases that you should be talking about, right? And then 90%, and this number is staggering, right? I look at AI coding agents every single day. So I think everybody is using it and should be using it, right? But not everybody's there. Not everybody's using AI agents for coding. And 90% in the next 3 years of enterprise software engineers will be utilizing AI coding agents if they're not doing that today. These are numbers that tell us that the adoption is really getting to a point where we are starting to see productivity, ROI benefits, business value from all the goodness of the updates that we've had in the architectures of the models, the advancements in connecting with other data sources that we have, with RAG and fine tuning, we are getting to a really good state. And if you're not already using it, or your business is not already thinking about these things, these are some of your pointers to get started. So next thing we want to talk about is how to fully realize AI's value, right? And just because everybody's using it, and just because we've got all the tools, doesn't mean we are going to get the most value out of it. Just like anything else, AI is the same. We get what we put into it, right? And I'm not just talking about data, I'm also talking about all the different, from resources to tech to infrastructure to models. We need to be very careful about how we're making all of these choices. Okay, so how do we fully realize the value of AI? I think it's four key pillars. The first and the foremost one is going to be the dev tools. We need to be choosing the right dev tools, and we need to be doing it such that it helps not just the coding, because we end up thinking and focusing way too much on coding assistance, but they're only 20% of the developer's task. Coding itself encompasses only 20% of what the developer does every day. 80% of the tasks are testing and reviewing and all the other things, securing, making sure that everything goes well in production, compliance, all of those things, right? And that comes in the end-to-end software development lifecycle. So we got to be thinking beyond just the coding agents and into the end-to-end workflow of a software development lifecycle. And that also means we need to be thinking about the time that gets wasted in tasks that could be done by AI, right? So think about, in the next 3 years or so, just like what the IDC is predicting, dev tools or developers' tasks, right? If you think of software development lifecycle, you're going from planning to coding, just building, I would say. Then you're going to testing, and then reviewing, security, I guess at every single level of all of the tasks that you're doing, and then you're going into deploy. All of those steps, and there are some mini steps in there as well, but all of those steps, you can imagine that there are agents at every single step. And yes, we've got agents for coding, we've got agents for testing today, AI agents, we've got AI agents to review today. But imagine the subtasks even being assigned by a human developer into each of these agents, while the human developer is working on another high-value task, right? So as you're thinking about that, you need to be investing in the tools such that your end-to-end software development lifecycle is becoming AI-powered and has AI agents, and it's not just 1 or 2 bits. And if you're doing so, then expand from there into areas where the task can help a developer become even faster, right? So thinking about tools in that way is important. The second piece to utilize AI more efficiently would be our models. Which model should we be using? That is an important decision, because you need to make this decision based off of what your use case is, based off of what the benchmarks for the models that you're assessing is. Do they work for the use case that you're looking for, right? So you should be using a platform that allows you to choose the right model, to evaluate those models, to make sure you can customize your models. And when time comes to actually edit the model, as well, I like to call it, to fine-tune the model to your brand, to your use cases, or to bring extra data into the model and make it richer and factual, doing RAG and AI agents and complexity of the workflows, which is orchestrating those AI agents with each other. All of these things are part of your model choice and how you're going to deploy the model. And you want to be using the platform that allows you to do all of these things end to end instead of just picking and choosing one at a time, because this is going to get really complicated really quickly if you're doing more than half of these things yourself or in different tools. So extremely important to think about that. Then the third piece is the deploy, right? And deploying, and I'm talking about deploying the app, because if you talk about deploying the models, I'm considering that in the model section. But in this deploy, we're talking about deploying the app, which is powered by AI, which is where we've used these models. And this is where we got to make sure it runs reliably for our customers. You go from POC to production. You're choosing the right infrastructure. Extremely important, because if you choose the wrong infrastructure, and I'll tell you what wrong is, right? Things are with AI, you got to be so fast in your deployment, so fast in getting your features out, because you're already becoming, you're competing with a lot of other competitors in your space that are also using AI. They are also trying to be more productive, and this is going to get even. You can see the number of features that come out every day now, right? The speed has become much more than we were talking about agile just a few years ago, right? And now this is like agile at next level. We're deploying things every single day, every single minute, if you will. Infrastructure is the core part of that, and choosing the wrong infrastructure can lead to lag. And so we'll talk a little bit about that. And this session today is all about infrastructure and how to make the right choices. The management of that infrastructure, making sure performance is important, and also reliability under real-world demands. And real-world demands, I want you to think about not just the scale at which your application is going to be used, because that is going to be real world, the number of customers that are going to use it, the number of requests you're going to get per second or per minute, right? But this is also related to your data is going to change over time, and how your customers are using your application. This is all going to feed back into your model, and how you're going to fine tune it, and how you're going to use this data to make better model, and to make better access to your internal databases and internal systems of records. So extremely important, those real world factors, and making sure that all of these deploy factors are, you're thinking about them before you even end up starting to think about the application itself, right? Then last piece is security. I would say it's not the last piece, it's the piece that you should be thinking about across every single time. How are you going to make sure the content is secure, it's governed, business risks are part of the whole thing, harmful and damaging responses from the model is part of the whole thing. Now, when we used to think about apps in general without the AI world, right, we still had all of these factors in play. But now there are new factors in play. Is my AI model going to respond with something damaging, something harmful? Is data going to leak out because of the usage of this model, because prompts could potentially leak that data? How are you going to manage? So there's some new factors that you got to be thinking about, compliance and regulations with AI as well. So there are some new things in security that need to be part of AI application development. So that brings me to, how do you fully realize AI's value? Think of it in 4 of these pillars: dev tools, models, deployment, and security, because all of these, and accelerating all of these and using the right tools in all of these pillars, is extremely important to be successful. Now, the next thing I want to talk about is, if you take all of those learnings that we did in the last section, how is it changing how we build AI agents? Since like 2022, we've been prototyping, and most companies we're at this stage where we're doing single models for applications and working on simple POCs and point in time ROI. It's helping me be 10% more productive. From there, we are moving towards, we're starting to see these trends already, multi-model situations where more than one models are being used to solve a particular use case in an app, automated agentic workflows, and continuous improvements, which means we're learning and evolving with the customer feedback and the data that we're getting in these apps. This is exactly what I was referring to here, as well. And this is happening more and more as our architectures are maturing, and the model architecture is maturing as well. So you're going to see that as a trend, and that means that there's more complexity, and the AI apps are going to get even more complex to manage and orchestrate. And then the other few things that I want to highlight are, there's currently we look at deterministic logic. I know we're talking about AI, but we still think in terms of the ages-old writing code methodology, right, which is deterministic logic, and we're just getting into the adaptive reasoning with the newer models, right? And we think about coding as code, build, test, versus now, as I was talking about in the previous section, we got to think about our thinking has to change into agentic software development lifecycle, which means that at every single stage of the development lifecycle, you have a human and an AI agent that are both working in conjunction with each other, taking tasks from each other. Then comes reactive monitoring and human-driven development, which means now that is shifting from reactive monitoring to proactive ongoing observability, as with things like SRE agent that can monitor your application in production and then dynamically adjust what's missing, or if the application's running out of a virtual machine, then add that into the mix and prevent the application from going down. Multiple point-based security solutions is what we're used to, and we use these for code vulnerabilities. We're going to use this tool. For application vulnerability, we're going to use this tool. For infrastructure, we're going to use this tool. All of that is getting consolidated into end-to-end security platforms as well. So we're going to see a lot more of that in enterprises. Okay, so those are the trends. And now, if we talk about how do we actually build the AI apps and agents, and this space, obviously, of building something involves a lot of different things. And so I want to leave you with the most important ingredients of the recipe of building AI agents, right? And there's lots of little things inside these, but if you think about zoomed out version, this is kind of what that looks like, right? The first thing you need is a data platform. This is where you're obviously storing your data in the databases, but there's a lot more to a data platform, because you're not just thinking about the databases, you're also thinking about external sources of data that are coming into your apps. These could be relational, non-relational, graph, vector, all of the different kinds of data that is required to then feed into your AI platform, right? And the AI platform, I call it a platform. And remember, I'm calling these things platforms, and not just data and not just AI, for a reason, because you require not just databases, you require them to be managed, you require them to be maintained, you require this data to be freshened up, and you require this data to have inputs from other external sources. And this requires a platform and not just a database, right? So similarly, when we talk about AI platform, this is for reasoning. You're going to use it to make your application reason. What that means is obviously, reasoning would require a model. You're going to make a model choice that is best for the use case. So your platform's allowing you multiple different options for different models. You can evaluate the models. You can look at these models through benchmarks and decide which one you want to use. And then once you have made those choices, you can fine tune that model and make it your own for your use case. Then you're going to build AI agents, and this platform should allow you to be able to build your AI agent and orchestrate them, talk to each other, talk to other things outside of the of your company, and operate these models. These things are just so operationally heavy that a platform should be able to handle all of that for you, so that you're focusing a lot more on thinking about what is my use case, and then what type of model I need. Does this platform allow me to do all of these things that I will have to do to make this AI application work? Right? Then next thing is there is integrations. Any application you're going to build is going to have to talk to either your third-party apps or different SaaS apps that are used in the company and outside of the company, and your current and existing internal apps. And all of that is going to happen through MCP servers and APIs. And that layer is extremely important. Think about no AI app is built on its own. There's going to be connections with your data. There's going to be connections with your models, right? And there's going to be connections with your current and existing and external and internal apps. All of these things work in conjunction, and you're going to do that through MCP servers. Now, AI apps and agents, these are all of these stacked together is going to build your app and or agents that you're working with. And that is dependent on your use case. That is why I went back into this. This is sort of that loop between the AI platform and the app. The platform is going to allow you to do all of these things that are needed to deploy your AI agents, but you're using the background platform to do that. Now, once you've made all of these decisions, you have the agents, you would need to think about the infrastructure. Let's come back to the infrastructure in just a second, but I want to talk about the two pillars that kind of span across all of these layers of the architecture, which is security and dev tools. Now, when you talk about dev tools, we covered the end-to-end software development lifecycle and how that's getting agentic in nature throughout the software development lifecycle. We got to be very careful that the tools that we're picking and choosing, or the AI agents that we're picking and choosing in that software development lifecycle is allowing us to be more productive, for the developers to be taking out the toil and introducing more fun work into the mix, right? And then the security aspect is, again, across the board. You need to think about infrastructure security, the AI app security, the integrations are secure, the platform for AI is secure, and the data platform is secure as well. So all of this end to end. So those are the two pillars that I think go everywhere. And then now coming back to infrastructure. And where should I run my app? I have the app ready. We talked about the infrastructure. We talked about all of the different components. Let's say my app, my AI agents are all ready, and I'm ready to put them into production. Where should I run them, and how should I run them? Would you use, at this time, with the speed and all of the details that we talked about here, with the pillars, with the way this is evolving and how development is changing, with where things are headed in adoption, you want to be extremely fast, extremely productive in deploying and managing and maintaining your AI applications, which means we gotta be using cloud native infrastructure. Otherwise, we won't be able to survive the wave, right? Yes, can you do it in infrastructure as a service? Sure, you would be able to. It's just a lot more work. If you have a lot more humans, and you have really big teams, sure, you can do all of that in infrastructure as a service as well. But really, if you want to survive all of these things that we are talking about and do it fast and be adaptable, gotta be using cloud native. And with that, we're going to talk to Brendan Burns, who's going to take us through all things AKS Automatic and why we continue to invest in Kubernetes from the cloud native perspective. Thank you very much. I'll give it to Brendan.
Cool. Thank you so much, Priyanka, for giving us the intro. And I'm here to talk about AKS Automatic, which we are GAing today and celebrating the GA launch, the general availability launch, which means you get to wake up my teams in the middle of the night if things go wrong. But we're talking about how we're going to simplify Kubernetes for the era of AI. And so we'll start, We're going to start with talking about how the modern app stack starts with Kubernetes. So the first thing I wanted to talk about is how, we're very excited about AI right now and everyone's thinking about AI. But the thing that I like to remind everybody is that AI doesn't exist in a vacuum. It has to run on top of a foundation, and that foundation is Kubernetes. And I think there was a great explanation of why, cloud native technologies help you ship apps faster. And in this world where, constantly AI is shifting and changing, and we go from, chat to agents to whatever's going to come next, agility is critical to meeting the success, either as a startup or even as an enterprise trying to deploy AI into your applications. But also, at the end of the day, we are businesses and we have to make sure that, we are achieving the right cost balance. So Kubernetes also enables you to densely pack your applications to drive up resource efficiency with either auto-scaling in horizontal or vertical dimensions. It additionally allows you to have portability, because I think another thing that we see in the world of AI is that data residency can be a critical part of an AI development and an AI application. And so being able to take an application that you've built in the cloud and built for the cloud and use the exact same tools and approaches when you are deploying it to an on-premise environment where maybe the data stays resident or the data stays local is a critical capability that you want to have. And obviously, we all want to hit the hockey stick. I've been through a few of those hockey sticks myself, and the ability to scale rapidly is a key component of what Kubernetes enables for you, because it allows that application, again, to be deployed into larger and larger clusters, or even in clusters around the world, as you discover that you're going viral in a particular part of the world and you need to suddenly deploy into Europe or into Asia or into another part of the United States. All of that is made possible through these portable APIs that are available anywhere in the cloud. See my slide. All right, there we go. And it also is the backbone for the ecosystem of AI that's being developed. I think that's the other important part. It's not just about how you build your applications, but it's about how you can take advantage of solutions that other people are building. So if you're looking for doing inference, if you're looking for doing fine tuning, if you're looking for connecting IoT devices out at the edge and the data there out at the edge to do video tracking or to detect problems in a fence or any other kind of environment where you want to be able to apply AI. We're actually using this for inspecting fiber and figuring out where a fiber cut is in our data center. All of these scenarios are unlocked via Kubernetes, and Kubernetes at the edge, Kubernetes in the cloud, and the connective tissue between those different environments. Obviously, the agility comes from the development of microservices, but also we're seeing with AI that we're also building these massive clusters to support training and very batch-oriented HPC workloads as well. And so this API surface area, the amazing open source ecosystem, they can all span you from small deployments at the edge, monitoring a camera feed or monitoring a drone, all the way through to hyperscale AI training clouds that have tens of thousands of nodes in them, all computing the next best model. And I wanted to reemphasize, or maybe as a proof point of this, talk about how Azure powers OpenAI's ChatGPT. You can see ChatGPT has just had an amazing amount of growth, and a lot of congratulations to OpenAI for all of that success there. And it's built on a backbone of Azure and built on a backbone of Kubernetes. So whenever you are running and using a ChatGPT API, or you're using ChatGPT through the interface, you're actually interacting with it on the Azure Kubernetes service. It uses Cosmos DB for a bunch of its storage because it needs to have that high scale, NoSQL scalable store in order to keep up with every new user who comes on and wants to set their preferences. Because, I think there's a lot of focus on GPUs and models and building AI applications. But the truth is that there's a lot of traditional app building that goes into building a successful AI application as well. You need to store the preferences somewhere. You need to store the history of queries somewhere. You need to store the history of responses somewhere, so you're not recalculating the inference every time. And all of that is going into Cosmos DB, which is our hyperscale NoSQL store on Azure. And of course, like most of the open source ecosystem and many of the applications developed by all of our customers, it's all developed out on GitHub, which is an amazing tool for not just maintaining your software and doing pull requests and that sort of thing, but also maintaining the connective tissue with your community. We do a really amazing job, I think, of maintaining the AKS roadmap out on GitHub and using that as a way that we can communicate to our customers and to our users, what features are coming next, when they can expect certain things, track issues that they're running into. It's a great environment, not just for development, but for connecting the social fabric of how we develop open source software. Here are some quotes, I would say, from a couple other, perhaps more traditional users. One from the head of engineering at Victoria's Secret about how the Azure Kubernetes Service managed to simplify all their processes and brought out a ton of things that they needed for their applications. As well as the CTO from Mr. Turing, who's talked about how instrumental AKS has been in the development of their application. So I'll let you read those. All right, but I think another interesting thing that really differentiates Kubernetes on Azure and Kubernetes with Microsoft is that it's not just about how we empower our customers, but it's actually how we also empower our own services. So across the board, whether you're looking at things like ChatGPT with in its integration into Bing, whether you're looking at Office and using modern work or Teams, if you're using Xbox and Xbox streaming, which I'm a big fan of and have used for my own gaming as well, or even a bunch of the work that GitHub is doing, all of these products are running AKS and running them at large scale. I think this is a critical part of why we differentiate what we do with Kubernetes on Azure, because it means that we truly are delivering mission critical services, not just for our customers, but for our own internal teams. It means we're held to a very high standard. And we're also very much focused on delivering the features that large teams need to deliver at scale, because obviously, Teams, GitHub, Xbox, these are all very important parts of Microsoft by themselves. And if we're not able to be the platform for them, then we're going to hear a lot from their leadership and from the broader leadership of Microsoft about what we need to do. So it's an amazing proof point that we're able to deliver for mission critical software within Microsoft, but it also means there's a tremendous focus within Azure on delivering the best Kubernetes experience, regardless of whether you're an internal user in Microsoft or an external customer of Azure. You're going to get that same high quality Kubernetes experience on top of Azure. But despite all of this value from Kubernetes, I think there's a ton of challenges to adoption that remain, right? Even as we use things like MCP servers to make it easier for you to understand how to deploy applications on Kubernetes, there's a bunch of operational overhead that gets in the way of you building your applications. Do you want to focus on, we just had a new Kubernetes release drop actually. And we actually had a release party where we went and read through all of the release notes and learned about all of the new features. But if you're focused on building AI applications, it may not be the best use of your time to go through the Kubernetes release notes and figure out all the intricacies and details of things that may have changed, APIs that may have adapted. And so by letting the Azure team do that for you, you can really decrease the operational overhead. You can also, by some of the tools that we're building, reduce the learning curve. We can hide a lot of the details that you need to understand to deploy a reliable cluster and do those things for you. you don't have to have, the SREs who are going to be your cluster admins. Azure and the Azure Kubernetes team can do that as well. And again, if we integrate well with tools that people are used to, like GitHub and GitHub Actions, it means that as you bring new employees in, as your business scales, your application scales, they're immediately productive. They don't have to become, Kubernetes experts in order to contribute to your application. So these challenges are all things that our customers were thinking about. And that led us to the development of AKS Automatic. And AKS Automatic, we're excited that it's now generally available. It's production ready. We've appreciate everybody who has been testing it in the beta period and giving us feedback and enabling us to improve it. But now it's available to anyone who wants to use it, production grade by default. And it has a ton of automation built into it to make your Kubernetes experience easier. So what that means is not only is AKS Automatic itself production ready, but the clusters that it creates, we believe, are production ready at the moment you create them. So you don't have to choose the right knobs. You don't have to set the right scale. The cluster is ready to go from the moment it's created. And then also, over the years that we've run the Azure Kubernetes service, we've learned a lot about how customers can run into trouble. And we've encoded those learnings into best practices and safeguards, which means that not only is your cluster production ready, but it will actually prevent your developers from making common mistakes. So these best practices are encoded into policy that is enforced at deployment time, which means that it is actually impossible in an AKS Automatic cluster to deploy an application that doesn't follow these best practices. And then finally, we have great integration of AKS Automatic with GitHub and GitHub Actions, and it enables you to go from code to deployed in minutes, which is an amazing speed up for all the application development that you want to be doing. All right, and so in order to have a deeper discussion, a more intimate discussion, we're going to invite a bunch of people, a couple of people, Sean McKenna, who's the lead product manager for the Azure Kubernetes service, as well as Amanda Wang, who's a product manager on the team, for an open Q&A, and it's going to be hosted by Corey Skimming, who's going to be our MC. Who is still muted.
I am muted. Of course I am.
No, she's not.
Awesome. Thanks so much, Brendan. And thanks, Sean and Amanda, for joining us to have a little chat about why we built AKS Automatic and what we see kind of the benefits being to customers and all users alike. So we will dive right in, and I have questions for all the folks on this chat, but we'll start with Brendan. So Brendan, when you co-created Kubernetes, what was the original vision for how developers would interact with container orchestration? And how does AKS Automatic align with or maybe evolve that original vision?
Yeah, I think the interesting thing is when you develop anything, the people who are the first adopters, the people who we were sort of building towards, they kind of want to tune every knob. They're the people who are excited about the technology, and especially in the first couple of years, they were the ones who really wanted to get in there and tune the knobs. But the vision was always that we were democratizing distributed system development, and I think at a point you realize that having to learn how to tune every knob isn't actually all that exciting. It's not really. Once you become really good at tuning a cluster, you're sort of like, what next? But we found people want to build applications, and they want to build applications on top of this platform. At the end of the day, it wasn't designed to just be a cluster. It was designed to be a place where you run your applications. And so I think with AKS Automatic, we're reaching that point where it really is something where the APIs are the things that people care about, and the implementation of those APIs are things that they would rather defer to experts to run for them. And so that ability to effectively continue to consume these open source APIs that empower and democratize distributed system development without having to worry about tuning every single specific knob is, I think, the thing that Automatic is delivering on. So I think it is delivering on that original vision. And of course, the Kubernetes community has grown to a point where most of the users aren't in that twiddling with every little knob world.
Yeah, so what I'm hearing you say is it was built for the nerds, and now we've expanded it so everyone can be a nerd. Democratize nerdism. Lovely.
That should be our t-shirts.
Democratize nerdism. Great. So this next question is for all the folks on the panel. So if you have thoughts here, feel free to chime in. We're increasingly seeing this shift from this concept of infrastructure as code to what some have started to call infrastructure as software. How does AKS Automatic represent this evolution to a more curated infrastructure experience, and what does that mean for developers and platform engineers alike? And maybe Sean, you can start.
Yeah, I was just say I can hop on that since Brendan's been talking for a bit. I see it as it's a continued evolution, a continued journey towards automating more of what doesn't necessarily add business value, right? We're on this continued journey of trying to remove work and toil that is undifferentiated heavy lifting for our customers. And so if you look at infrastructure as code, obviously that helped you automate the creation of infrastructure, but you were still ultimately involved in deciding what infrastructure were you going to be deploying and what were you going to be automating the creation of, right? And so if you look in the Kubernetes context, Kubernetes cluster is made up of a set of machines, and even in a managed Kubernetes environment like AKS, the customer is still on the hook to decide, okay, what are the set of VM SKUs that I'm going to have power this environment, right? And that's what I'm actually putting into my Terraform or ARM template. And so, as Brendan talked about, really, as you want to move more towards the application layer, oftentimes you don't really have a lot of desire to be down in the weeds of deciding what type of VM SKUs you're going to need, because you're operating at the container level, and really you just want compute that is going to meet the needs of your application. And so in the context of AKS Automatic, that's where we've introduced the concept of node auto provisioning, where you just deploy your applications and then the service is going to make intelligent choices about what infrastructure to actually put into that cluster, and not only on sort of an initial basis, but on an ongoing basis, right? So as we are continuing to add, do more innovation at the infrastructure layer to add additional types of VM SKUs and types of hardware that is more efficient, more optimized, your environment can just take advantage of that. Whereas often we see folks sort of set the initial set of infrastructure that they want to use in their cluster, and then they sort of leave it there, and they end up falling multiple generations behind, and they're not getting necessarily the best sort of price performance. And so that's an example of where the platform is able to just take more of that toil away from you. And so for developers, that obviously means you can go and spend more time building applications and building innovative features. I think from a platform engineering perspective, it allows you to really focus in on what is the type of curation that you're doing for your specific organization, your specific industry, right? Where the things that you can really be building bespoke logic and curation and templates versus doing some of this undifferentiated sort of operational toil that really doesn't differ that much from whether you're running in finance or oil and gas or a nonprofit or what have you, right? So it's that continually sort of moving up the stack.
Yeah. Amanda or Brendan?
Yeah, I think the other thing I would add, though, is that I think one of the things we always try and strive for is you still feel like you're running the main, right? I think that's what differentiates, maybe what we're building a little bit more on the infrastructure side from like a true, platform as a service, right? I think we want to relieve you of operational toil, but leave you still in control and leave you in control of the important parts, right? And so I think that's the balance that we're always trying to strike with products like this. I think we've done a great job of hitting that point with Automatic. And of course, I think as part of that vision, it's Automatic is composed of pieces that you could put together yourself. And so, if it turns out at some point you want to hit the eject button, that's always a possibility. So we maintain that freedom where you can have ease of use, but you can also have sort of graceful and gradual degradation to a more manual system if that's where you need to go.
Yeah, and just one thing to add to that, I think starting with a cluster that's production ready and with all of those knobs pre-configured for people that might not want to do the research themselves or is just overwhelmed with all the things they have to do is a really great way to get started. And as they maybe get more mature and now they have more bandwidth to do some digging into Kubernetes, then like Brendan had mentioned, they can always switch out to the regular AKS and then do additional innovations on top of that.
Yeah, so platform engineers who are looking to tee things up to make life easier for the developers have some nice control to be able to do that. Developers who just don't want to touch the underlying operations now have an easier on-ramp as well. And Brendan touched on this a little bit, but Sean, I did want to ask you around how AKS Automatic fits into Microsoft's broader cloud native strategy, especially for those customers who are newer to Kubernetes and might not have all of the skill sets to do all of that knob turning that Brendan had alluded to previously.
Yeah, totally. So yeah, I think as Brendan mentioned, Kubernetes itself is core to our strategy within Azure, right? He talked about some of the large external customers like OpenAI that are running it, but also internally, right? The likes of M365. I always say, so one of the biggest litmus tests of a platform in Microsoft is, are we willing to run Office on it? And we certainly are in the case of AKS and Kubernetes. So it's really core to our overall platform strategy. And you see us doing investments across the portfolio that see Kubernetes as kind of the application platform target of choice. Very often, historically, we would have thought of just raw VMs as the place where we would center a lot of our investments, and increasingly that's moving towards thinking of Kubernetes as being that foundational layer. But yeah, as Brendan talked about, what we've seen the journey with AKS, which we launched back in 2018. So 7 years in at this point. Initially it was very much a niche service for the customers who wanted to live on the bleeding edge, right? Who oftentimes were coming from running Kubernetes themselves directly on infrastructure and wanted just a fairly lightweight managed offering because they came in with a whole set of opinions themselves of how they wanted to run things. And so that was sort of the initial market that we were going after. But now 7 years in, we're very clearly into the middle of sort of mainstream adoption. Basically, any customer in Azure of any meaningful size has got some application workload that they're looking to run on Kubernetes. But for a lot of them, they're not coming in with a strong set of opinions. They say they know they want Kubernetes for the portability, for the ecosystem that it provides, for the flexibility of the platform, the ability to really run the entirety of their app estate on it, but they don't necessarily have a strong set of convictions about how they want to do it, right? They want Microsoft and Azure to tell them, hey, this is what we've learned from all the customers who have come before you, all the things that they've maybe gotten wrong or tripped up on, and all the best practices that we've learned through that process. Just distill that down for me into something that I know is going to work out of the box and is going to feel like a curated experience and not something where I might have put the pieces together in the wrong formation and now I'm running into an issue. And so for those customers who are coming new, we think this provides them that sort of curated chef's choice kind of menu, if you will. But again, as Brendan alluded to as well, that you're not locked in, and I think Amanda said as well, that you're not locked into that set of choices, right? So if any point you get to the stage where either you chose wrong or more likely that your requirements changed over time as you had additional needs that came in, that is as simple as just sort of removing the safety. We sort of take it and move it into a standard cluster, and now what you've got is a cluster that's set up with all best practices, but now you have those additional knobs at your disposal. So we really think it's something where you don't have to have that upfront analysis paralysis of like, oh, am I going to need all of these extra knobs down the line, and therefore I'll take that path just in case. I can go down the automatic path, and then if I do need to change course later, it's a very simple switch over, not a migration or anything like that.
Yeah, so we're enabling folks to take the best of what others have already learned in running these over the last many years, and enabling them to not have to think about what others have already learned and focus on innovating and maybe learning new things in their path to deploying and running applications and increasingly large scale AI applications. I also love the chef's choice analogy, so there will be some food references being thrown in from here on out. Amanda, so let's hone in a little bit more on kind of the developer experience. So you're the product manager for AKS Automatic. when the team were designing AKS Automatic or thinking through the end user experience, what were some of the key developer pain points that the team heard most often? And how did those insights shape the product philosophy into what we've announced as GA today?
Yeah, we've heard a lot from developers that, again, they really want to focus on building the application and not necessarily managing the infrastructure. They don't really want to wear two hats when they're really busy developing the application itself and also iterating on that application as business grows. A lot of the themes that we've heard around application developing and running it on Kubernetes is around how do they configure all of the options that Kubernetes itself has bring, and also kind of combine that with the diverse offering that Azure has, from storage to security, etc. And also as they develop their application, as well as kind of shifting the application to production, observability is also another big common problems that they have, both from kind of combining all of the application observability tools that they have, and then also when something does happen in production, how do they really troubleshoot on sort of where the problem is, looking at all these tools and all these logs, really quickly narrow down the problem. And then lastly is around security. How do they ensure their application is sort of like secure by default? They don't really have to worry about the security, but more on kind of sort of like what problem does the application solve. So with all of these in mind, we design AKS Automatic to try to solve these problems. So we've already heard that AKS Automatic comes with a lot of best practices built in by default, and this is based off of our experience as AKS running a lot of the Microsoft products, but also other companies out there, and we really baked that into the product itself, and then also limited some of those choices that you have, because there's a lot to choose from Kubernetes, but also the open source ecosystem that CNCF offers. So we've taken some of the sort of like most popular ones, or the ones that we've seen a lot of adoptions. So from an observability standpoint, Prometheus and Grafana is baked into the AKS Automatic cluster. So these are tools that developers are already familiar with, so they don't necessarily have to do a lot of on-ramping, and they can just take this AKS Automatic cluster and get started with all the observability and troubleshooting that they have to do. And then on the security front, a lot of the default is baked in, so it allows different permission configuration. If maybe multiple developer teams are sharing the same cluster, all of that is configured, and it also limits a lot of the more privileged access to the containers itself to kind of keep the workloads running there securely.
So what I'm hearing you say is that AKS Automatic provides mise en place for developers, to lean into the chef analogy. No, that's great. That's great. And I think one of the things that's really at the heart of AKS Automatic is, making sure that we're building a great experience for developers. So all of those things are, critical components of making that an easier and a better and a more delightful experience. Switching over a little bit, Brendan. So you've watched Kubernetes grow from, an internal project at Google to the foundation of modern cloud native computing. I think in the 2024 Cloud Native Computing Foundation report, something like 80% of companies are running Kubernetes in some capacity in production. What patterns have you seen in how successful organizations adopt and scale their Kubernetes as, the project and the community have grown over time?
Yeah, I think the first and most important thing is that, and this is a universal truth, not just a Kubernetes truth, which is that technology will not fix your organization. So, I think throughout all of this, earlier when we were involved in DevOps, there was a lot of people who were like, we'll just DevOps the thing, and then we're going to, all the problems will go away. And so I think the first thing is realizing that these technologies and organizational or social arrangements of your teams, they go hand in hand, right? Yeah. And so Kubernetes is really about empowering developers and handing over control to automation. And so, that shift from, and I think Automatic is part of that shift from I need to be at the keyboard to this thing is going to fix things for me automatically, is a recurring theme, I think, for organizations that do it successfully. I think we saw this early on with automatic security updates, which is probably the first sort of like automatic feature that we built, years ago. But it took us a while to build it because honestly, people, they wanted to be at the keyboard when the security update happened, right? But then eventually people realized like, oh, you know what, actually the trade-off of having to be there actually means I slow down the security patches that I get. Right? I don't get them as quickly. I'm not as ready. And so I'm willing to let go of that control. And so I think good organizations, whether at a team level or at a how I use Kubernetes level, figure out how to delegate the right things to the systems that know how to do it well and focus their energy on the things that are only things that they can deliver, right? We can't deliver your application for you. You need to deliver your application, but you can delegate security updates and auto-scaling and best practices configuration to us, and we can do a great job of that. And I think that's, again, how we find organizations doing a great job is that delegation and trust. And that applies to the humans as well.
Yeah, that almost brings up an interesting pattern or arc as we think about the current wave and shift to agentic patterns and the need to establish that trust in agentic models, kind of in the way that it needed to be instilled in those more automated processes right off the bat.
Yeah, and I think actually the best practices and policies actually play a role there too, right? Because if you've configured your cluster to follow best practices, you can, in some sense, trust the agent more as well, because you know that it can't do something that doesn't follow best practices, right? I think, the same kind of guardrails that we want to put up around, humans who you've onboarded apply to agents that might take actions as well, right? And I think obviously it's a very evolving space, but we're pretty excited about the ways in which it can relieve a lot of toil, both for developers and operators. Automatic is about relieving toil. I think the agentic work that we're doing with MCP for AKS and otherwise are also about reducing that toil.
Yeah, who doesn't want to reduce toil? Spend more time doing fun things.
Exactly.
Awesome. So Sean, the next one's for you. Kubernetes, as we talk about all these expansive use cases, Kubernetes has sometimes been criticized as being almost too powerful for a lot of simpler use cases. How do you think about balancing giving teams the full power of Kubernetes while still making it more approachable?
Yeah, I mean, in some ways it's a funny critique, right? Because, usually people don't want to give up power, right? If they have something that is pretty powerful at their disposal, they'd like to be able to maintain that, even if they can't necessarily use it initially. It's sort of a human psychology thing of loss aversion, of not wanting to give up something. So I think when people say that, what they're really saying is that, initial onboarding for an application that might not be able to, or might not need that full power, at least at first, the trade-offs of that complexity to be able to get that first workload running are a bit difficult, right? And so then you get into that, well, do I think I'm going to need that full power down the line, or would I rather go with something that's much simpler? And so really what we're trying to find with AKS Automatic is that middle ground where I sometimes describe it as sort of being able to skip atop the top of the Kubernetes API and sort of the full power of that platform, right? Where I'm able to get all of that, a lot of the benefit without having to get into the weeds of it, at least initially, but that it's there for you as you grow and as your requirements change, so that you don't ever hit that cliff of, oh, my simple application grew and added new requirements in, and now I actually do need some of those knobs, and they're just not there at all, right? And now I need to think about making a move to an entirely new platform, which again leads to some of that upfront analysis paralysis that we see from customers of like, well, am I going to need that down the line, or should I go with a different option right now? And so we're just trying to find that middle ground where it's all there when you need it, but you aren't faced with that complexity up front because we've curated an experience for you that allows you to get those initial workloads online, start to see some of the benefits that come with it, but with the the freedom to be able to use that full power later as your requirements dictate.
Yeah, makes total sense. And I think that scoping exercise of what do I need now versus what do I need in the future is a challenge that a lot of enterprises and companies of various sizes run into when building out their applications. Amanda, I'm gonna pivot back a little bit to AI. So I don't know if you've heard, but modern apps are increasingly AI first, or at a minimum AI enhanced. To build on what Brendan talked a little bit about earlier in his section of the keynote, what, in your opinion, makes Kubernetes particularly well suited for these workloads? And at a high level, how does AKS Automatic remove barriers specifically for teams building AI applications?
Yeah, so I think we still think of AI apps as another iteration of application. Underneath the hood, there's really nothing that's drastically different, and we've already seen from the entire ecosystem and a lot of different adoptions of Kubernetes that Kubernetes is sort of the platform to run their applications. A lot of the benefits that Kubernetes itself has offered, such as extensibility, portability, the ability to scale up and down as sort of demand to your application grows, all of these are really great for your applications. And that doesn't necessarily change for AI applications as well. AI applications can still really take advantage of what Kubernetes has to offer. And kind of thinking on top of that, when we were developing AKS Automatic, again, it's more about how do we make sure the application experience is great for the developers? How does the applications itself run very securely, and also with all of those best practices built in so that developers don't have to worry, but now they can really leverage sort of the power of AI to either build applications faster than ever, or kind of build more intelligent capabilities within the AI application to do things that weren't possible before without AI. And also we offer things like GPU node support on AKS Automatic. So for customers that might be doing more traditional inferencing or deploying ML workloads, they can also have the capability to do that. And oftentimes they really appreciate kind of the peace of mind that they get with AKS Automatic, where they now only have to focus on the model itself without having to think about how to manage their Kubernetes cluster on top of that.
Yeah, and it's funny to hear us think about inferencing, more traditional inferencing already at this stage. The rate of shift to this has been so fast. But your note that AI apps are apps, I think, ties in really nicely with what Priyanka was talking about in her keynote earlier, where she's saying, nothing is built in a silo, right? Like there is the AI component, there's the data component, and the platform is also an important component in making sure that you're able to operate and scale and build out any apps in a feasible, scalable way. Brendan, looking ahead and thinking about what we just talked about in terms of AI workloads, how do you see the relationship between AI workloads and container orchestration evolving? There's a lot of chatter in the Cloud Native Computing Foundation community around the role of cloud native and AI. What excites you most about this intersection?
Well, I mean, I think that the thing that's most exciting to me is the problems that we can sort of take away from the people who are trying to do AI development, because one of the things it's useful to understand, I think, is that at-scale training and at-scale inference would have been a lot harder to achieve in a broad way without something like Kubernetes, because your first step of every AI application would be like, okay, figure out how to connect 10,000 computers to each other, right? And because we started this container orchestration place, a lot of problems, whether it's how do I package the software, how do I deploy it reliably across a whole bunch of machines, it's just solved for you. And I think what we're seeing now is the cloud native community starting to say, okay, what additional problems could we solve in an AI-centric way, right? So we used to have load balancing. Maybe now we need to think about request routing as a first level concept. I think with some of the tools that we're building in systems like Keynote, we're starting to think about maybe fine-tuning is a concept that we can take advantage of, right? I think one of the things that has always been in the Kubernetes API has been, how can I take an idea and allow you to use the idea without having to know how to implement that idea, right? So one of the very first, sort of like killer demos was zero downtime update, right? We will put into the Kubernetes API the ability to update your software, right? And I think at this point, 10 years later, people are like, of course, my platform should know how to update my software, right? But like 10 years ago, that was a feature, right? And I think we're going to see that same evolution in AI, where things that people have to do themselves today, whether it's figuring out how to do distributed inference or figuring out how to route a request to different models, depending on the complexity of the query, those are just going to be things that people take for granted. That, of course, my cluster provides me with these capabilities. And then I can focus my energy on, the crafting the prompt, or, there's parts of your application that will always be specific to your business, specific to what you're trying to achieve. And I think that's also probably one of the more exciting things about Automatic as well, is us figuring out, right now, Automatic is very general purpose. It's for anyone who wants to build any application. But I think over time we may see like, oh, actually, there's an Automatic for specific use cases. Right, so we're going to help tune for, inference serving, or we're going to help tune for some other vertical in the industry. And I think those opportunities of figuring out what more undifferentiated heavy lifting can we take on are exciting, both for the cloud native community and for the Azure Kubernetes team to do in both places.
Yeah, and that ties back into what we were chatting around in terms of things that used to be a manual have to do eventually become best practices that we can build back into the platform and offer to people to remove some of that additional toil as we learn from what everyone is doing. A quick one for the panel. If you had to predict how developers will be building and deploying applications 5 years from now, what would be different? What would stay the same? Will it all be done in Copilot?
5 years is a long time, so we can all go out of over our skis and get this wrong. I mean, I think at a high level, as Brendan was alluding to, continuing to find places where you can add more business value. That's always going to be an evolution, right? Where it's like, how can I apply the limited hours that I have in the day to having higher leverage, where I'm doing things that are really specific to my business needs, and getting more and more away from sort of being in the weeds of the how, right? I think the thing that's going to change, in fact, that we are seeing already with the likes of AI assisted development, is moving much more towards an intent based kind of development model, right? What is it that I want to build? How can I describe the requirements and the needs that I have at a high level, and then guide these platforms towards getting that right without having to be down, as Brendan talked about, being right at the keyboard, dictating every single piece of that, right? And so that's a little bit of obviously what we're doing with Automatic, but also, as you suggested, with the likes of Copilot, where it's more about guiding these tools to meet those business needs versus having to be really down there in the weeds. I think that's going to be an ongoing evolution as well.
Yeah, I think I think about the journey from the first computer I started using. It was text, right? That's it, right? And any understanding that you needed to put in there were arcane little combinations of characters, right? And so over my 40 years in the computing industry, what has happened is we've gone closer and closer to being able to just express what we want, rather than have to shape what we want to match what the computer could understand. And I think, and I hope that that's just going to continue. It's going to take some interesting focus on building out things that do a better job interpreting that intent and turning it into something that actually works 100% of the time, right? But I think that's the direction that we're headed in. But I think the other thing that is very true through all these technological developments that I've seen is that all that meant was there was just more work to do. It's just bigger, more complicated work, right? So the things that you thought were impossible today, because all that toil is taken care of via automation and AI, become possible, in the future. Kubernetes wouldn't exist if we're still writing in assembly language, right? There'd just be too many assembly language instructions to write, right?
Yeah, and I think one more thing to add is we've seen pretty recently there's a lot of change around how AI can really help with prototyping and getting sort of an idea onto, I guess not onto paper, into the terminal and spinning up an application very quickly. Even for people who may not have had coding experience at all, that's something that's been super powerful. But I think sort of in the future, really getting an application that's ready for production workload and kind of for more real world use cases and is able to handle the things that continue to matter a lot, like performance, reliability, making sure the application is secure and kind of really making sure that's ready. And then also more around how do we collaborate with each other, really gathering the whole organization together to kind of empower a more seamless collaboration with AI in order to kind of, learn from everybody and really put something together in order to build something great.
Yeah. So what I'm hearing from all of you is that there's this level of almost like democratization of development. And I'm sure folks who have non-tech folks in their bubbles have had people come to them and ask them about vibe coding or things like that, right? Like everyone has had this experience by now. And the other piece here being that that developers also have to be more intentional about almost communication, right? How are we communicating with our teams and setting up these requirements? And how are we communicating with AI in order to make that intent understood and build things in the way that we do intend? It's a very exciting time. And we're just at time. So we have one last question for Sean. And I'm going to ask you, what is your one key message for development teams who are considering their next gen application platform strategy?
Yeah, so I guess, tying together some of the themes that we've talked about today, I think you always want to be maximizing your long-term flexibility while limiting your upfront complexity and cost, right? And so by flexibility, I'm talking about the ability to run different types of applications, different technologies, and different environments, right? It's very rare these days that we see customers who only have one type of application that they want to build, one set of technologies that they want to use, or one type of infrastructure and environment that they're going to run on. And so, ideally, you want a platform that's going to easily support running a variety of those different types of workloads, right? We talked about AI workloads as kind of the hot thing right now, but the reality is we've got a lot of customers that are dealing with legacy applications as well. And so you want a platform that's going to be able to span the set of microservices that are built in Rust to a Windows legacy application that might have been written 10 years ago in ASP.NET to those AI workloads, and be able to do that all in one place. And that's something you also want to be able to run in different environments, right? Whether that's in public cloud, on-prem, at the edge. And so, that flexibility is something that Kubernetes brings in spades, right? This is why we see a lot of customers adopting it is for that power that we talked about earlier, and that flexibility. But as we talked about, it does have occasionally some of that upfront complexity that people worry about. And so, with Automatic, we think that gives you that good middle ground of being able to bet on the Kubernetes API that has that flexibility and portability and all the ecosystem that comes with it, while really limiting the upfront cost and complexity, so that you have easy onboarding, an easy way to sort of grab the lowest rung of the ladder, but that ladder goes all the way to the top, if you will. So finding that balance, I think, is pretty key to picking a platform.
Wonderful. Thank you for those thoughts, Sean. And thank you to Brendan and Amanda as well for joining us for this fireside chat. Super great discussion. And, we spent a lot of time talking about the philosophy and high level of AKS Automatic, and I'm sure folks are itching to get into some of the actual technical details. So I'm going to welcome Jorge Palma to the stage to do a deep dive into AKS Automatic specifically. Thanks, team.
All right, folks. Hope you're excited as I am to dive a little bit deeper into Automatic. We've heard from the team a little bit on the philosophy of it, as Corey mentioned, and I really want to walk you over to some of the details of what makes Automatic, and then lead on to our demonstrations, because I'm sure that you're also kind of itching to see it in action and what it accomplishes. First off, we already started to hear from folks like Swami that have been using Automatic throughout its preview, of how faster it's been allowing them to prototype, and how it's been allowing them to do exactly what we expect, which is to speed up the time that they get to production, allow them to focus on the applications and their workloads and their business at the end of the day, and not just infrastructure or having to deal with configurations or their environment setups. And we're going to see a little bit of how that's possible with Automatic, how Automatic makes that easier and enables you to focus on that exactly. In AKS, and as Brendan mentioned before, it's kind of the house for modern applications. We had many dozens of thousands of customers that are using it. We have 96% of Fortune 500 using it. It's super scalable and has a ton of this functionality. It's been a very healthy race with Kubernetes itself to try and provide complementary services, like providing managed add-ons or managed features for a lot of the functionality that Kubernetes provides itself. So we've been priding ourselves to provide essentially everything as a managed operation, everything as a managed component, while still maintaining all that choice and ability for you to pick your own story and to pull from any open source project and install it and run it in Kubernetes. But that, and as Amanda was mentioning, we've been hearing from a lot of different folks across the industry, a lot of our customers, and there was still some complexity. You've heard from folks that one of the key things that sometimes users faced is if they were completely new to Kubernetes, completely new to cloud native infrastructure and distributed systems, there's a learning curve to it. And there's misconfigurations that could happen across, like, are you using the right settings? Are you putting the right information on your workload manifest? Are you deploying your cluster with the right features and configuration knobs for what you need? Maybe it's a test environment, maybe it's a production mission critical environment. And then there's the overhead that sometimes happen when you moved from prototyping into actual production readiness. Yeah, Kubernetes and AKS already allows you to very quickly, stand up a cluster and start deploying things into it very easily. There's several tools we provide on the development side to do so. Our portal is very rich in that functionality as well. But when you then moved into production, when you moved into securing it, when you moved into, is my network optimized? Do I have the right availability constraints and more? That overhead increased. And sometimes that what was a few hours of prototyping very fast can actually then turn into a bit longer. And as Priyanka mentioned, sometimes that coding piece and that initial prototyping piece was much faster than the second part where you were trying to productize it and put it there. So because of it, and as Brendan mentioned, we are really happy to be GAing today AKS Automatic. It's been now in preview for the past year, and we've had great feedback from folks. And I think a lot of you might be asking, okay, so what's the difference between Automatic and what we call AKS Standard today? So Automatic is a new SKU that takes on a fully opinionated path, a pre-configured, if you will, set of options that we designed and that we observed in the industry, but that we also match to our best practices and to the things that we stand behind as the right way to develop distributed applications, to develop AI apps, modern apps, and more. And it has a number of functionality from AKS, and it derives from it, and you can actually change between both. So as long as you align your existing AKS cluster to the Automatic configurations, and we have the objective to make sure that you can't, from any cluster, go to Automatic, so that there's nothing, you don't need to rebuild clusters or do anything like that. But you do need to align it to those best practices. You do need to align them to that recommended path, which in Automatic is the only path. so that you can then turn on Automatic for it. So we divided this in 4 different pillars that we're going to deep dive a little bit more on, where we take care of the networking, the compute selections and choices and scaling, how we make the environment secure and ready for production, and also make it easy to observe and run it in production, as well as our safeguards and best practices that are enforced through Azure policy, as Brendan mentioned. And we're going to run through a few of those and what they are. One question that you might have is, okay, so what is Automatic versus standard? What are the differences between both of them? And in a nutshell, there's 2 key things. First is from a functionality perspective, you can achieve most functionality from AKS standard in Automatic. If you build it yourself, if you configure it yourself as of today. All those knobs that I mentioned before, you can turn them on in Automatic, you can create that. So if you have a platform team, or you're part of a platform team or a central team in your company that is creating those, you can very easily create like a landing zone for AKS and have all these settings properly configured, take and leverage all the functionality that we're talking about here, from auto upgrades to security patching to delivering namespaces to developers, to have built-in scraping of and monitoring. All of these things have the right choices, can be baked in there, but you need to set those yourself. But we don't have a huge goal to make Automatic have functionality that you can only achieve there. We expect to have that functionality to be spread across both Automatic and standard. Where the difference really lies on the second piece, which is on management. And we really want to take care of all operations, of all day 2 tasks, of everything that essentially basically makes you spend time not developing the application, not focusing on your workload, not focusing on your business. If that is a task today there, we are either already taking care of it, or it's going to come next. And definitely Automatic is GAing today, and we're standing behind it. As Brendan mentioned, you can now wake us up middle of the night if there's any issue with it. You can call us for help, for support, and we're glad to take that call. But it's not stopping here. There's a lot more that's going to continue to come. We have more events coming up later the year, like KubeCon in Atlanta or Ignite, where we're going to continue to enhance and again take care of more and more of these tasks that you might need to do, such as the day 2 tasks and operations, like monitoring, for example, and take them onto our own essentially plane, provide SLAs for them, and much, much more. And so for that, you might also ask, okay, so with all of that more in terms of management provided, is there a difference in cost? And the answer is it's the same model, but there is a difference in the cost. So much like with AKS, you're paid for what you consume, and you have a cluster fee for essentially the managed components that we run on the control plane, and for the SLAs that we provide for them, essentially our work of handling them, of patching them, maintaining them, etc. And so that's the same model that Automatic also has, except you have basically the price, and that fee is specific for Automatic because there's more components that we mention that we manage, and there's more management operations, as well as the management plane, like the nodes. They are, I think, as Sean mentioned, leveraging auto provision, which makes the bin packing for them, as we're going to see, a lot more efficient, and therefore the pricing for that compute is also specific to Automatic. So it prices the same model, same philosophy, but with a different price point of standard. Now let's take a look at the different pillars that we see here. So first we have networking. So in networking becomes one of the first choices that you need to typically do when you're planning. All right, so which networking plugin and which networking control plane and data plane do I select? What are my CIDRs? Do I need to bring on my VNets? What options do I select for my inbound, and what about outbound? So all of these are taken care of in Automatic. Again, you create an Automatic cluster. There's no knobs for you to select in any of these areas. It comes in with our Cilium eBPF-based data plane. It comes in with our Azure CNI overlay for the control plane, and it delivers our highest performance networking and security stack in this area. For routing, in terms of inbound for your applications, it comes with application routing, already used by many thousands of customers in production successfully over the last few years. And that delivers our layer 7 ingress to the cluster, and it integrates with Azure DNS zones, with Azure Key Vault for both your certificates and DNS, and also integrates with your existing ones if you use third-party or different vendors for your DNS and certificates. And finally, it uses our VNet integration capabilities that went GA earlier this year that allows you to have a always private connection between your nodes and your API, as well as ensure that you can change just in time the access to the API server from public to private if you want to. So for example, you might always have it private. You might use something like a Bastion or Cloud Shell in the VNet, or you might want to just in time give public access, give it a public IP, like what today we call a public AKS cluster. And then the API can be, for a little while, accessible publicly from a network perspective, even though from a security perspective, that is still secured by Entra ID, for example, as well as for authentication and authorization in both cases. Next, we have compute. And we talked a little bit about node auto provisioning and how it delivers that bin packing. Of course, it has the capability to serve both CPUs as well as the much needed GPUs for everything that is related to models or AI apps. It leverages our Azure Linux distro for our nodes that guarantees our supply chain, and we manage the full supply chain for these clusters and these nodes with patches for critical CVs delivered within 5 days, guaranteed, and continues to have all the SLAs that AKS already has today for our API server, for our underlying compute, and more. And as I mentioned, we continue to expand on those with more and more functionality and more management in the coming future for Automatic specifically. Now, let's take a quick look into how does that compute work in Automatic. So you're typically scaling, and there's usually 2 dimensions for scaling. You want to think about how your application scales into multiple replicas, and you want to think about how your infrastructure scales with it. So when you're scaling your application, you're typically either scaling it horizontally or vertically, meaning that you're either scaling to more replicas of your application, which usually is represented by a pod in Kubernetes. So 1 pod, 1 replica, and you might scale from 1 to 10, for example. Or you might want to scale it vertically, meaning that you will typically scale it and grow it its requests and limits. When that happens, you might need more resources for your infrastructure. So you might typically need the ability to scale the infrastructure according to the new requests and limits for your applications. So when you grow from 1 CPU to 2 CPUs, you now might need more nodes that allow you to run not only that 1 CPU application, but run the replicas that need 2 CPUs each. So that's where the infrastructure scaling, like node auto provisioning, comes in. That allows you to just in time respond to that, but not just grow it, but also scale in, meaning reduce when it's no longer needed. And that might happen when you're doing a spike, but it might also happen when it detects changes in pricing or capacity or other different nuances in Azure. So that if you're using 4 VMs that are fully packed, there's no scale in necessary, right? You're fully using your infrastructure. However, there might be a cheaper option. Maybe it will start using Spot, or maybe there's now the ability to run ARM64 and your applications allow for that. And so during its consolidation cycles, it can further bin pack, for example, from those 4 VMs into 2 VMs that still deliver maybe your availability constraints to be separated across zones, for example, into 2 zones, but gives you a cheaper price point. And so it was always consolidating in the maintenance window of the cluster that is also automatically configured in Automatic, and that you can tweak if you want to change the timing. It will always have and will always deliver this consolidation across the board for the clusters. And of course, if you want to scale your application based on a number of variants, from the application metrics to the traffic it's receiving to the time, because a spike is coming in when there's a lot of new workers coming into work or exiting, or things like queues or even database entries. That's why we have KEDA, our Kubernetes event-driven autoscaler, baked into Automatic so that you can make use of it right away. And that is also integrated into our tooling that allows you to deploy very easily, that you're going to see throughout our demonstrations. That makes Automatic not only have these components, but also making them easy to use and make that path of prototyping to production much easier. So when you look at something like a cluster that is using node auto provisioning backed by Carpenter, you essentially have a number of workloads. You see different ones, for example, that like the blue one, the green one, and you want to essentially bin pack them and pack them the most efficient way possible. So what you see on the right without the provisioning is that you have workload blue all packed in one node, that D2 PSV v6 node, and then two more nodes, including one spot node that was available and has capacity available in a totally different SKU. So auto provisioning works across all the SKUs that you allow it to. By default, it's all the Azure SKUs, and it will choose the best combination possible to again achieve a level of bin packing as you see there, which is just enough to receive maybe another replica and another scaling of the application, but that's just about it. Anything more, it will continue to scale, and it will also consolidate further as necessary. The next is, what about security? Can we make sure that security can we make sure that all the security pieces are in the cluster at the time of creation, as well as reducing on all the materials that you might need to add onto it or that you might need to secure later on? So on one hand, you have Entra ID for authentication and authorization, and you have Azure policy, as well as our restrictions for node access. So on one hand, you are going to always be required to log in, like when you do for the Azure portal or the Azure CLI. You're going to be required to log in, at least the first time, and then you're going to be able to, for as long as that token has validity, leverage that token to access the cluster. That's for authentication. For authorization, you're also going to be able to use roles in the Azure portal or the Azure API to guardrail your access to that cluster, so that you're not just relying on, for example, Kubernetes role bindings and roles inside the cluster to do so. You can create your own rules that you can use across, for example, all your clusters, and you can give access more widespread, but also still granular, maybe to specific namespaces or to specific teams that have access only to that. Furthermore, we're restricting a number of capabilities that usually cause the most amount of issues that we see a lot of our users use inadvertently. Maybe it's a simple thing that some open source project is using. Maybe it's just the easiest way to prototype at the time, like leveraging root access on the containers or the pods. And we're now essentially restricting that to use only the necessary capabilities, ensuring all the best security from pod to pod and from namespace to namespace. And that is enforced through our Azure policy integration that leverages the open source Gatekeeper and OPA projects. So you're not going to be able to, as Brendan mentioned before, deploy into the cluster in a way that is against the cloud native best practices and against what we see as the best practice for the cluster. And that will be blocked at deployment level as well as runtime. You're going to get an audit if something changed inside the cluster somehow. You're going to still be able to see something in red showing up in your compliance dashboard. And furthermore, every infrastructure piece inside of an AKS Automatic cluster is now fully locked. Not only the nodes you can't access through SSH or RDP into them, but you also can't touch any piece of infrastructure inside of that cluster. So everything inside of what we call the node resource group is fully locked in, meaning that only AKS can manipulate it, only Kubernetes can manipulate it as well. Now, the other point is, for regards to upgrades, there's been a number of features and capabilities that AKS has baked in over the last few years that are all available in Automatic, such as our automatic security patching, our automatic Kubernetes upgrades, and not only with that, but also with our breaking change detection, so that if any application or any component in that cluster is running and making use of any deprecated API, that will make sure that it won't upgrade, it won't start the upgrade. So when you're, for example, let's say, using an API for Ingress or for scaling that might be in beta and that graduates to V1 and that beta eventually leaves, that cluster won't start an upgrade because that beta API is not in the next version. So the cluster will let you know, and you can update it in that version and then proceed with the upgrade. Now, the potentially more important thing in an automatic cluster around this is because of that limitation that it delivers to your clusters, it actually will prevent you from deploying a lot of these things in the first place, so that none of these capabilities that we baked in for both standard and automatic need to kick in, because you're not allowed to deploy things that, for example, are missing PDBs, and then we need to do a metrics check, or are using deprecated APIs, and then we need to detect that and stop it. You're going to actually be essentially forced to deploy according to the best practice using GA APIs and more that don't take those kinds of dependencies, so that it will minimize any issues that you might encounter as part of an upgrade. Next, we have observability. And in the observability front, we have essentially all the integration that you can expect from an automatic cluster, where you have built-in Grafana dashboards, built-in Prometheus, as Amanda mentioned, and all the automation to resolve any issues with the nodes as well as with the cluster. So you can expect that all your applications are going to typically be automatically scraped. All your infrastructure is going to be automatically scraped, and it will light up in the Azure portal and in the built-in Grafana dashboards that Automatic provides for you. You can continue to create your own, especially if you already have experience with it. But if you don't, you're just going to get all those metrics, that richness coming out of the box for you, and your logs are going to flow straight up to Azure Monitor and to Log Analytics as well, allowing you to leverage automatic alerts that we create for you, as well as create your own if you choose so. So this is essentially looking at the Azure portal, what you typically will see automatically coming out of the box when you load the Grafana dashboards in the Azure portal. You'll see all the different dashboards you can look at, all the different metrics already pre-populated for you, allowing you to see things like the CPU utilization, in this case is for your compute resources. You can see the differences between utilization at 3% to the requests that you're placing there, which are typically at 47 for CPUs, and the limits commitment or overcommitment in this case going at 400%. So clearly you can already look at this and see that there's something you can probably optimize in this case, because you're probably requesting a little bit too much for your application than what your usage actually ends up being. So maybe reducing those requests would allow auto provision to scale in and make that more efficient. But you also see a little spikes there, so maybe not all applications are actually the same. And so you might need to look at some of them and see, okay, these ones I can reduce, but maybe those I need to keep the requests in to be better for my spikes, or at least maybe the limits will work well enough for that. With regards to deployment safeguards, you've seen Brendan mention it, that this will essentially guarantee that you cannot deploy with misconfigurations, and these are enforced at deployment and runtime by Kubernetes, essentially webhooks that do mutation and admission, and will effectively change your deployment or block it if it doesn't respect the best practices. So you'll see things like not deploying with requests and limits. You'll see things like deploying with root access or with advanced capabilities being blocked, not having security context. So all of these things will be safeguarded, and you see the full list in our safeguards policy initiative that comes in with Automatic. And you can also leverage your compliance dashboards in Azure Policy to see everything that is being applied to your cluster and what the specific policies are. So you're going to see things such as availability. You're going to see things such as default spread and requests that will help you with cost management. You'll see things such as security, and all of these are going to be baked into deployment safeguards in Automatic to make sure that your teams, even if they're not professionals and they're not already very experienced in Kubernetes and AKS, are going to be able to still make use of Automatic for the future. Next, we have the built-in security enforcements that safeguards also have. So I mentioned already root access, but you could see things such as preventing host access itself. You could see things such as blocking specific Linux capabilities. And we also have additional safeguards in the nodes themselves, in our Azure Linux nodes, that prevent those kind of escalations, lateral moves, and different exploits as well. So as we mentioned, and I think Amanda mentioned that before, our key goal is how do we create the easiest Kubernetes experience for our developers that allows them to prototype very effectively without then spending a lot of time going to production or needing help or needing to read throughout the plethora of documentation from AKS and Kubernetes. And Automatic is not just all about the platform itself providing you with those guarantees. It's also about how do we create an experience that delivers the simplicity for you. So if you don't know, okay, so you're blocking me from deploying everything that isn't following best practices, but how do I know the best practices? And the answer is by leveraging the Automatic toolset. So one of it is that we just recently announced is managed namespaces. And managed namespaces allows you to deliver namespaces to a team or created for yourselves that already offer logical isolation. So you're going to have default network policies built in. You're going to be able to select the requests and limits for the namespace that will apply quotas to that namespace that will then make sure that every application, every deployment, replica set, stateful set deployed there will be within those boundaries. So you can deliver those to teams specifically, and then prevent or allow communication to different namespaces and applications by default. And you can change that over time as well. So you can configure them with specific labels, so you can identify which teams they are, and do cross charging for cost and much more. We also have automated deployments, which is for all of you that were thinking, okay, so I can't deploy if I don't follow best practices. How can I inform my developers of those best practices, or how can I know about those best practices? That's what automated deployments and draft actually do, is they create the manifest for you, and based on your code that follow these best practices. They already contain things like pod disruption budgets. They already contain things like health probes and readiness probes that make sure that your deployments will then deploy to Automatic. So you can see these two things as Automatic gating your production readiness and your ability to survive, upgrades and any different availability events. And you can see automated deployments as the way to deliver those manifests that are compliant and compatible with Automatic, and that will simplify your usability as well. Now, what if you already have manifests? What if you already have pipelines? Because automated deployments doesn't just create the manifest, it also creates automated pipelines, CI/CD pipelines, to deploy those things to the cluster, so that you're not directly deploying these things via kubectl, for example. You want to be deploying those via pipelines. So what happens is that you can just reuse. So you can use automated deployments only for the pieces that you need. So imagining that you already have a Docker file, when you're running through automated deployments, you can just select your existing Docker file and it will generate the manifests and pipeline. If at the same time you have one of the others, you can do the same. Maybe you want to generate the Docker file, but you actually want to tweak the manifest, or maybe you've ran automated deployments before and it already created a manifest for you and you already did some changes, and that allows you to get that automation delivered for you. And as Sean mentioned, this is the place where you most likely are going to be able to start popping the hood using a more car analogy. Automatic serves as that, maybe either car leasing or app-based writing app. And it actually delivers the ability for you, however, to still pop the hood of your car and start to learn a bit more about its mechanics. So you can allow automated deployment to create everything for you, but it just generates a PR. And so you can still go into that pull request and observe everything that it created and maybe start tweaking with it. So if you want to start learning how to do better health probes for your applications, how to do better readiness probes, and continue to increase your knowledge, you can do so. And then you can just update those in your code repository and manifests and continue to use the same pipelines that automated deployments already set up for you, or the ones that you already set up yourself. Finally, Service Connector actually allows you to connect to be it databases as well as different Azure services with workload identity and key vault access. So you don't have to figure out, again, how to do changes in YAML and changes in clusters in order to consume different Azure services like databases or OpenAI services to connect to your apps. You can simply use Service Connector for it, and that will allow you to very easily, just through a portal flow or through an API flow or through a CLI flow, connect your application one to your database one, your application one to your OpenAI service, and from there, then put that into infrastructure as code so that every change that you do, you can just always have it fully in your repository and it will be delivered via a pipeline. So this leverages workload identity, it leverages Key Vault, and all the secrets and everything is taken care. It's put on Key Vault for secrets, it's leveraging workload identity for authentication, and there's nothing that you need to figure out on how to put that infrastructure together. It will just use it automatically for you. And as I mentioned before, in the observability space, AKS not only automatically will scrape your infrastructure, it will also scrape your applications as well. So you're going to be able to have live metrics sent to things like application map or live metrics, which will allow you to observe things such as HTTP requests and latencies, and allow you to see if there's something wrong with your application, create your own alerts. And all of this, you don't need to instrument your application, do code changes. This a simple annotation in your namespace will start scraping using the App Insights OpenTelemetry distro that today already works for Java and Node.js, and will be expanding to more languages in the future. We are now close to time, and so I definitely want you to go and actually see everything that I've been talking about in action, and I will pass it on to Ahmed and Paul to show you that. But I want to end up with going back to our goal, which is to make AKS the easiest Kubernetes platform for developers. And we have a number of different tools for that, from our CLI to the Azure portal to local environments like in Headlamp. They are also open source, and that you see on the right that you can use at large to simplify that and to make sure that, yes, you're using Automatic, you have kind of your ride sharing a cluster essentially sometimes with different teams, but that cluster is driving itself. And so you want to leverage that, but at the same time, you want to leverage the ability to very easily deploy to it, make use of all the different tools that Kubernetes and AKS provides. And if necessary, you want to have the ability to transition to standard or to pop the hood, as I mentioned before, and do your own tweaks because maybe your application necessities changed and you now have a lot more, you want to have a lot more flexibility at that time. All right, so with that, let's actually take a look at what Automatic looks like in action with Ahmed and Paul.
Before we kick to Ahmed and Paul to do a live demo of AKS Automatic in action, we're actually going to hear from a longtime AKS user on their perspectives on AKS Automatic.
Hi, my name is Satish Krishnan. I'm a distinguished engineer in the financial industry. I have had the privilege of working on AKS since 2020. I think, in my opinion, AKS Automatic is an experience of Kubernetes on Azure, where a lot of things around, a lot of plumbing around how the infrastructure and platform components are handled is taken care by Microsoft and not by the customer. Today, our usual cycle is we deploy a cluster, then we choose between Nginx as an ingress controller or Istio add-on. We manually configure the plumbing, and then we configure Azure monitoring with the log analytics for logs and Azure managed Prometheus and Grafana for metrics. And this happens for every clusters that we do. And I think, in my opinion, this should be standard. When I build a cluster, I should have monitoring, I should have load balancing, ingress out of the box. and which is what AKS Automatic promises. So from my DevOps perspective, going forward, I would only have to build a cluster and then get ready to deploy my application, and it at least be relieved of the overhead of having to manage add-ons and other best practices. Having used Azure Kubernetes Service since 2020, and I've seen how it evolved from where it was just being an infrastructure and a platform layer on top of it to a full-fledged PaaS service in its stage right now. The challenges that developers typically had was around choosing which is the right add-on, how do we do observability, how do we connect observability with the add-ons. It was always been a challenge, and not everyone can keep up with it, and which is one of the reasons why we often see no two clusters in our organization look similar. And from a DevOps perspective, again, it becomes a challenge where you now have to define, although we can define a golden path, every team then has some of the other changes that makes it difficult for the DevOps team to follow a standard practice, and keeping up with the Kubernetes and add-on version often becomes a big challenge. And finally, when it comes to operation, due to the nature of how clusters were created, every upgrade cycle for the application teams is now takes between 2 to 3 months, because we need to make sure Kubernetes version, add-on versions for Istio and other components that we use, like KEDA, we have to make sure that they are compatible, and we are bringing in the latest version of the image that doesn't bring our application cycle. So these are usual challenges. And then from scaling perspective, we often have challenges around which is the right SKU to pick for my workload. And with AKS Automatic, I think it addresses most of these challenges. It is an opinionated setup that comes by default with Nginx or Istio as an ingress controller. It has all the security rules built in. Azure managed Prometheus and Grafana becomes available out of the box for monitoring. And then from a SKU perspective, with the introduction of Carpenter as a managed add-on, AKS Automatic can help us choose the best SKU depending on the type of the workload that we deploy. So which means now I less worry about infrastructure and more worry about how my application is deployed and how my application is scaled, and leave the infrastructure aspect fully to Azure Kubernetes Service.
Hey, Ahmed.
Hey, Paul.
How's it going?
Good. It's a great day.
Big day today, huh? Awesome. So I guess now it's our time to show all this stuff in action, right? We've been kind of talking about it all morning. Had some great keynotes by Priyanka and Brendan. Great round of Q&A. And then George just kind of went over all the high-level features of AKS Automatic. And so I guess now it's time to see some of this stuff in action.
Let's do that.
Just gonna scratch the surface here, but go ahead, Ahmed.
Yeah, I was saying let's do that.
Yeah. Okay. So what we're gonna do is we are gonna walk through how you can push your application to AKS Automatic cluster when all you have is source code. No Docker file, no Kubernetes manifests, just code to cloud in a few minutes. Now, I will tell you that these demos right here, they are recorded because this stuff takes a little bit of time. But what you need to do is head over to the Azure portal, navigate to the Kubernetes Services blade, and then click on the create button. You'll see a fresh new deploy application button, and you'll be prompted to either try a sample application or deploy your own. Okay. In this case, we're going to deploy our own application, and the interactive guide will basically walk you through picking a resource group and a region for your deployment. These choices determine where the underlying Kubernetes cluster will be provisioned. Once that's set, you configure a workflow name, and then you link it to your source repository. It could be GitHub, could be Azure DevOps. So once the repository is linked, it'll basically, the platform will generate automatic pipelines so that you can build and deploy your code. If you don't have a Docker file for your application just yet, the platform can also generate one for you. All you need to do is tell it where to save the file. And here we just point it to the root directory, and then AKS will automatically detect the application type. If you have a container registry, it'll automatically pre-select that for you. Otherwise, you can create a new one and create a new link. From there, just add an image name. And then I typically use the same name as the application. And then you want to choose whether or not you want to use existing Kubernetes manifests or create one for you. Similar to the steps above, I'm just going to have it generate the manifest for me. And all I need to do is tell it where to drop the manifests within the repo. Here I'm picking the root. And then at this point, AKS will basically scaffold the deployment, service definition, and includes many of the Kubernetes best practices, including basic application scaling rules, health probes, and pod disruption budgets to protect availability. It also will configure a service, which I'll come back to in a bit. From there, you just need to choose whether or not you want to create an automatic cluster or use an existing one. Here, we're going to create a brand new one from scratch. So we're going from code to cloud, literally. You add in the cluster name, and then you choose the automatic upgrade scheduler. So you can choose a schedule that best meets your business needs, right? Fill in the Kubernetes namespace in which you want your application deployed into. And then note here that the Microsoft Entra ID authentication in Azure RBAC is enabled by default. The monitoring is also configured automatically. If you have existing monitoring resources, it'll automatically pick that for you. Otherwise, you can create new resources on the fly. At this point, we're presented with the review page. We can scroll through, make sure all the details look good, and then double check the contents of the Docker file and the Kubernetes manifest. If you're starting from scratch, the auto-generated Docker file, it's a great place to start, but you should iterate on that and make it better over time. Same goes for the Kubernetes manifest. With the auto-generated files in place, you can hit deploy, and the platform will basically spin up all that infrastructure and create a deployment pull request for you. And that's it. Streamlined, automated path, take you from code to cloud within a few minutes, all without writing a single Docker file or Kubernetes code yourself. Okay. What happens next? So next, once the cluster is deployed, it'll issue a pull request and put that into your repo, right? And so what you need to do at this point is basically click that approve pull request button. It'll redirect you to your Git repository where you can review all of the generated files. Here, you'll see the GitHub workflow, which is the thing that automates the entire code to cloud pipeline. But let's focus in on some of the Kubernetes manifests a bit. We have a config map, a deployment, an HPA, and the service. Remember, this tool scaffolds the file. You're in control here, and you can review and make edits where you need. In this case, the service is created as a load balancer. I don't want that. I want to use an ingress, and so I'll change this during the PR review, change it to cluster IP, and then commit the change, and eventually merge this PR back into my branch. Once this is merged, I can optionally delete the branch, and then the GitHub action workflow will automatically trigger, and we'll start to see the deployment pipeline running. So it's built the image, it's deploying the Kubernetes manifest, and my application is starting to roll out into the cluster. Okay. Once the deployment is complete, we can return back to the Azure portal, and we can see the status of our automated deployment. Shows it succeeded. We love that. Green is always good. And then we can navigate to the workloads blade in our AKS cluster and filter for the demo namespace. That's where the app is living. You'll notice that the deployment is ready. Now let's check the status of the service. We see the cluster IP, or the type is cluster IP. Yes, that's great. Now we want to expose our application using Ingress, which uses the AKS application routing add-on. Since we don't have an Ingress yet, we can literally just click create Ingress, and then on the Ingress blade, give it the same name as the service and ensure that it's in the demo namespace. From here, we can select the TLS certificate to use. I already have a wildcard certificate uploaded to my Azure Key Vault, so I'm going to use that. If you don't have a Key Vault, you can create one here, but it's probably best to have it pre-provisioned with your cert already uploaded. I also have the domain aks.rocks and registered it with Azure DNS. So all that remains is to create a subdomain for the site. So I'll just make the site called flights.aks.rocks and click create. Behind the scenes, the application routing add-on configures the Key Vault access policy so that the certificates can be pulled from the vault and injected into the pod. And then the add-on assigns the required DNS roles for DNS zone management. So it's basically going to create a new subdomain. At that point, all I do is click through to the Ingress and start testing my site. With the AKS Automatic cluster, you basically have a super easy way to operate your cluster. Most of the cluster tasks can now be done via the Azure portal, which makes it super straightforward. But you still have the power of the Kubernetes API, which is really great for those that are accustomed to using kubectl to perform tasks, right? And you can do that too. And we'll do that in the next section here. So let's reconfigure our application scaling resource to use KEDA, a managed add-on for AKS. You remember that scaling logic that I said I'd come back to? Well, in order to use KEDA, you need to remove the HPA resource because KEDA has its own internal HPA controller, and it wants to create the HPA and control it on its own, right? So we grabbed the kube config from the cluster, then we deleted the HPA, and next we'll return to the portal and we'll set up the new scaling strategy using KEDA. And the portal now lets you create a simple KEDA rule directly via the UI, which is really nice, especially for those getting started with KEDA. I'll create a new rule, give it the same name as the deployment, and link it to that in the namespace. I'll set my minimum number of replicas to 3. And since I feel like this is more of a memory intensive application rather than CPU intensive, I'm going to trigger off of that and set the memory threshold to about 40%. After reviewing the configuration, I'll go ahead and click create. And with KEDA in place, the cluster will manage application pod scaling through its internal, through KEDA's HPA controller. And then as the load increases, application pod demand increases, and so will the number of nodes to meet the scheduling demands. Okay. AKS Automatic, as mentioned earlier, defaults to using node auto provision, which is basically the managed implementation of the open source Carpenter project. So this is basically your node autoscaler. Let's now verify that our application meets user demand by launching a load test using the Azure load test service. So we can head over here, and I'm just going to flood the application with a bunch of requests, and we'll see that the load test is running. And with the load test executing, we can jump back over to the terminal where I'm using K9s to just monitor the number of pods and the number of nodes that get spun up. And at the same time, you'll see the node viewer at the bottom. You'll just see a bunch of nodes coming online to meet the need of the pod scheduling demands that's put on by KEDA and the HPA. Once the test subsides, now I did fast forward this like, I don't know, like 100x or so. But once the test subsides, the HPA will eventually scale the pods back to the minimum number of 3. And then, of course, it also shrinks down all the node pools accordingly. So in just a couple of minutes, we can see how we were easily able to go from code to cloud in just a few clicks in the portal.
That's awesome, Paul. Is the website actually still live?
You know what? The website is live. So let me see. I'm gonna flip over to here. This is my real terminal. And for the folks on the call or on this live thread, and maybe our lovely producer Anna can help us here. But I invite everybody that's on the live stream now to head over to flights.aks.rocks. You'll see this website up and running right now, and maybe we can crowdsource a load test right here on the spot and see how this does. We're gonna put these scalers to the test.
Yeah.
So with that in place, we can just keep an eye on this just to see how it's doing. I don't know how many users are on the call. We may get a spike, we may not. It could be that our application is just handling, but right now we have 3 pods. We have a few nodes, and we're looking pretty good. And I do see a killed, which does happen from time to time. And here we go. We are starting to see a spike. There we go. We're coming back online. So feel free, have fun with the site. That's what it's here for. And with that, Ahmed, you have a couple more things to show us.
Yeah, I think with load testing, crowd load testing in place, I think the next thing we should be doing is looking at monitoring and how to monitor that deployment and how to monitor that cluster. So I'm in the AKS portal, in the Azure portal right now, under the cluster that we deployed. And I'll head over to the monitoring blade over there, so I can see what monitoring comes out of the box. And let's maybe switch to the last 30 minutes just to get like more up-to-date information. So under the cluster summary here, you can see what nodes are up, how many pods are up, the CPU usage across all of the namespaces from the cluster. Typically, like the data just showing the cluster utilization at large, so that you can see at a glance how things are going. You can also see like the logs and events that are being stored into Prometheus, or scraped into Prometheus and into Azure Monitor, where you can see like click through things and see what logs are coming out there. This runs KQL queries, so you can see all of the system SCD out logs that are coming out of your applications. And you can also see data on networking and also the API server or control plane metrics. So beyond that, I can also set up recommended alerts. And these are alerts that use Prometheus scrapers. So there are a couple of alerts that are already set up for like node usage and memory usage. But I can also set up Kubernetes specific alerts as well, things like crash loop backups, like pods that are crashing, node level metrics, and also cluster level metrics. So I can switch those on, and I can get notified by email, but I can also get all of these notifications in the portal. So I'll set this up, and while it's going, we can also see what monitoring settings we have in place. So the cluster is already configured to connect to our Azure Monitor Managed Prometheus instance. We have an option to also enable Grafana, but you can see that that is not enabled, and I'll show you why in a second here. And you can also configure the log level, or how many, what's the level of logs that you want to collect. So logs and events is typically the most cost-effective log setting, but you can also optimize that. So you can go here and you can come here and maybe just include the namespaces that you want to collect logs from, or maybe you want to exclude things, like you want to exclude logs from Cube system, for example, from being collected, just so that you can focus on your application logs. So I'll not touch that. That looks fine to me. And yeah, if I click on View Grafana, there's no linked Grafana instance. You can definitely create an Azure Managed Grafana instance, but you no longer need to do that if you merely want to use the built-in dashboards, because now we have the functionality built into the dashboard or built into the Azure portal, which is called the Dashboards with Grafana, and that is currently in preview. The way it works is that it connects your Azure Monitor Managed Prometheus instance, and it comes with a lot of the built-in dashboards already in place. So things like looking at the cluster resources, cluster compute resources by namespace, pod utilization of the nodes. You can look at networking logs as well. And if you enable things like network observability, you can get even deeper analysis. So things like DNS requests and pod flows, you can get really deep into there. So let's take a look at the namespace dashboard, for example. So what this shows you is it connects to the our Prometheus data source here, and then I can filter that by the different namespaces in our cluster. So if I switch to the demo namespace where the application is deployed, you can see that I have 10 pods running of my application pod there. You can see the CPU limits. I can see memory usage of the application. So you can see, like, yeah, looks like you guys are successfully load testing here. So I can see a spike in load going on. So thank you for that. You can see the network consumption, the network usage, lots of very useful data here. But not only that, I can also browse the Grafana dashboards gallery. So Grafana dashboard gallery has a lot of community provided and community contributed dashboards. So let's say, for example, I want to look for a dashboard that visualizes our Nginx ingress usage. So if I search for Nginx in there, so I can find a couple of useful dashboards. So for example, this one filters or shows the data from the Nginx ingress controller. And to import that, all you need to do is to copy the ID of the dashboard and then go back here and import a dashboard by its ID. So I know, Paul, that you've actually deployed the service metric or the service monitor resource to actually scrape the metrics from our Nginx ingress controller. So that's why this will work out of the box now. So let's go there, and I can create a dashboard. And I'm going to deploy this in our same resource group and pick the Prometheus instance to get the data from. So now we have a functional dashboard that we just imported off of the community gallery. So this is showing the metrics that are coming from the Nginx ingress controller. I can even filter that by like the namespace of the ingress, and I can pick specific ingresses as well. So I can see how specifically an ingress is doing. So you can see how many requests per second are coming through. So you can see here there was a spike of 15 requests per second. I suppose this is around where we ask you to go and run the load tests. You can see the CPU usage coming or being consumed by the ingress controller. And you can see the ingress controller response times and latency, and a lot of useful information there. So with that, Paul, what else can we do with AKS Automatic?
Yeah, so that was a great overview. And just a quick question for you. is there anything anybody needs to do to enable the dashboards with Grafana?
It comes out of the box with all AKS clusters, and it
Oh,
actually
nice.
comes at no extra cost. So as long
Nice.
as you're just using the dashboards with Grafana in the Azure portal, you don't have to deploy a separate standalone Azure Managed Grafana instance, and you can just use that for your visualizations.
That's pretty cool. Yeah, I was looking at the dashboards that you were showing, and it looks like pretty much identical with what I'm accustomed to looking at in Grafana itself. So that's awesome. Yeah. So to answer your question, what else can we do with the cluster? First of all, let's see. Thank you for everybody that was load testing. I saw my the number of pods were going a little haywire for a little bit. And I think Ahmed, you're showing traffic spikes there. So good stuff. This stuff is holding up pretty well, I would say. So we got a couple of pods running on 2 different nodes. And if you're curious on the tools that I'm using here, I'm basically using K9s up top, and then the AKS node viewer in the bottom pane here. So these are all open source tools. You can go out and grab those and use them in your own environment as well. So what else does this do? So cluster and app deployment is automated with AKS Automatic. Monitoring configuration is also automated. And as folks have mentioned on the previous segments, cluster compliance reporting and enforcement is all automated as well using Azure Policy. So let's take a look at some of that stuff. So let me just make sure one more time. Does the site reload? Yeah, the site reloads. Okay. All right. There's this feature of AKS that AKS Automatic enables out of the box called deployment safeguards. And deployment safeguards is basically here to help ensure that your compliance, your cluster compliance, is always on point, always on always stays green, right? So let's take a look at that. So I'm going to start from the reports and then work on down to the actual cluster terminal level. So let's start from a higher level. Let's start with Azure Policy. Okay. For those of you that have been working in Azure for a while, we know that Azure Policy can help you govern your Azure resources. And when AKS actually enables this feature of deployment safeguards, a policy set or an initiative is basically assigned to your cluster resource. And you can actually view that within the policy compliance dashboards here. And so one of the clusters that I have where this is enabled, this is the, no, this is not the cluster. This is the cluster. So this is the cluster that we've been working against thus far. And you can see here that it is basically an initiative assigned to the resource. And then here, down here, you can see a list of all the different policies that have been written to where we can start to govern and monitor and make sure that folks working in your cluster are actually doing the right things, you know? Things like ensuring liveness and readiness probes are in place, right? Container images shouldn't be using the latest image tags, you know, things like that. So it's a lot of the best practices just written as Azure policies and packaged up into an initiative. That's the way this thing is enforced. And I don't want to get too deep into the weeds, but basically what happens is this solution leverages OPA or the Open Policy Agent, which basically translates these Azure policy rules into Kubernetes rules. And that's how they can be enforced on the Kubernetes side, right? And so if I were to scroll up over here, and if I take a look at the view assignment, initially when this feature rolled out, it was rolled out with a audit assignment. So let's see, where is that? Edit assignment. Let's edit the assignment. Okay. So this stuff is version, and you can see here that the policy effect is basically audit, right? So anytime I do anything against the cluster, if I do like a kubectl create and I just have bad practices built into my pod templates or deployment templates, it's going to give me a warning in the terminal. And then on the compliance dashboard, it's going to show up red, and it's going to pinpoint and tell me exactly what resource is out of compliance, all the way down to the Kubernetes resource. So whether it's a pod, a replica set, a deployment, doesn't matter. The Azure policy is going to pick it up and let you know that this sort of stuff, is out of compliance. So like, you can just turn it on, put it in audit mode, and you can find all the resources that are just like out of compliance. Like I think I saw somebody in the chat saying they did a painstaking process in looking for pods or deployments without liveness and readiness probes. Like this policy could have been super helpful in that case. Let's take a look at the other option in deploying this stuff. So if I go to this one, I think this is the right cluster. Let me just double check here. When it's done loading, come on. Okay, so this is it. So if I go to edit assignment, and we just take a look at what it is over here, edit assignment. So this is actually using a newer version of the policy set. So the AKS team actually stays on top of this and kind of like iterates through all the policies and updates them. You can actually click here, and you can see all the different versions, and you can also automatically enroll in all automatic upgrades of minor versions, right? So you can do that as well. I won't do that for now, but let's see what the policy effect is over here. So policy effect is over here is deny, right? And so what does that mean? Well, let's take a look at it. So I'm going to back out of this, head back over to my terminal. Okay, so it looks like people are done testing the site. Thank you. So what I'll do is this. I think I need to change my cluster. Okay, so I am connected to the other cluster where the deny is in place, and I can do this. I could do a kubectl create deployment test, and here I'm just running a imperative command, and I want to run the latest Nginx container image. You'll see here that it says failed to create. Admission webhook kicked in, right? And then it'll start to tell you exactly why. And I think this is container image versions. Yeah, so because I use latest, and then also things like liveness, readiness probes, right? And so these admission webhooks will actually inspect your deployment template and say, nah, sorry, we're not going to let that happen. So that's pretty cool. Now let's see what it looks like on the other side. So config, and if I switch back to my other cluster that's in audit mode, and if I do a kubectl create, this should go through, right? But this time it left me warning messages, right? And so it's telling me, hey, you don't have any resource limits. Maybe you should try using an explicit version. And so policy scans every, I don't know, I think 15, 20 minutes. Don't quote me on that. I know it just takes a little bit of time, but eventually if I go back to my compliance dashboard, that green check mark is going to turn red. And then it's going to pinpoint me to this exact deployment and let me know that this thing is out of compliance. So that's kind of like another thing that AKS Automatic helps you do. It helps you stay green. So
yeah. And with that as well, I wanted to share something that with the general availability of AKS Automatic, we're actually rolling out mutations. So what will happen is that the cluster will always remain in the unforced mode.
Okay.
But we will help you by mutating the requests when we can to automatically add in like missing resource and request limits if you miss them out. Generating liveness and readiness probes for you if you don't have them in place. So mutating the requests when we can to add things like pod topology spread constraints to spread the pods across different hosts.
Yeah.
When we can, and for things that we can't change. So for example, we can't detect which tag you want to use on the image. Those we'll still have to block, but essentially we'll be automating and mutating those things on your behalf to make you stay compliant.
That's pretty cool because
Yeah.
writing pod topology spread constraints is it could get a little tricky.
That's true. This is rolling out right now, so we'll be there
Cool.
pretty soon.
Yeah. Cool. So let's see. We spent a lot of time talking about infrastructure, right? And we're supposed to be in the mode of operations where, hey, we don't really need to think about this anymore. Things are supposed to be easy. When are you going to get to the AI stuff? So it's probably the next thing that I'm going to show you. Okay. So let me head back over. Let me close this. Bum, 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 bum. Okay. I will head back over to my Contoso Air application. Okay. I think everything works. Yeah, everything works. Okay, good. You might have noticed this. There is a chat icon. Okay. Basically, AI engineering, super hot right now. I don't even need to tell you that. You probably just know that. AI engineering is the hottest thing right now. Using models in your app is becoming just as ubiquitous as using a database in your application. To me, I feel like every app needs an AI-enabled component to enhance your user experience. Could be a customer, could be internal user. So here, I'm gonna show you how you can easily integrate AI models, specifically Azure OpenAI, with applications running in your AKS cluster. So here, I'm just going to say, hello, we're going to test this thing. And it's going to say, nope, sorry, failed. I don't have the proper configuration in place, right? And so what are we going to do to hook the application up with AKS Automatic? There's a component that George talked about, service connector. And I'm just going to show this really quick little whiteboard here. Basically, service connector, there's a lot of things that goes into connecting an application to any resource. Could be database, could be a large language model, doesn't matter. You have to do things like put the identity together. And then if you're deploying it to Kubernetes, you have to do things like put the service account together, put the secret together, put the config map together, and then you have to update your deployment. That's a lot of stuff going on over here. Service connector actually takes care of all this for you, right? So, and that's not a great square. I just want to do this. I'm going to do this. Service connector will take care of this bit for you right here. Okay. It'll take your OpenAI resource, which is over here. It'll take your identity over here. It'll link those two together, create a federated credential, and then basically generate a Kubernetes resources, service account and secret, so that you can actually use them in your deployment. So let me just show you one way to do that. Let's go here, and let's do AKS connection create. So I'm just going to use Azure CLI just for the sake of getting through this pretty quickly. But I mean, I was quite pleased with how easy the Azure CLI command is actually structured. So all you need to do is say AZ AKS connection create, and I'm pointing to cognitive services, which is Azure OpenAI. I'm basically saying source is my AKS resource ID. Target is my Azure OpenAI resource ID, which I already pre-provisioned. And then the workload identity resource ID, because remember I said service connector will take that identity and kind of tie it between the two things for you. And so that's all you need. Oh, one important thing, super important thing. The namespace, because it's going to create Kubernetes resources in the namespace, right? So we'll let that kind of do its thing. I know not a lot of people are terminal people or CLI folks, so I want to show you what it looks like. So if I go over here, and then if I scroll down, so there's a service connector thing over here. What I can do is, okay, you can see my thing is creating. If you wanted to do this through the portal, it's pretty easy. Pick a namespace. I'm not going to do this. I'm just going to walk through this real quick. Pick a namespace, pick your target service. Okay. And I have to choose the one specifically. And then over here, literally just workload identity is what I'm using. I pick my managed identity, which is, no, not that one. Not that one. I think it starts with ID. Yeah, that one right there. That's it. Okay. At that point, if I click advanced, you can see here that service connector will assign the appropriate role to the resource. In this case, I'm pointing to Azure OpenAI. So it's going to give it the Cognitive Services OpenAI contributor role. And then check this out. So these are the things that are going to be created as secrets inside of my Kubernetes cluster, right? And so if you remember, yeah, go ahead, Amit.
So my app can actually use these same environment variables then to make the connections, right?
Yeah. Because take a look at the names here. So Azure OpenAI endpoint, right? Azure OpenAI client ID. And if I go over here, endpoint is one of the things that my application needed. Azure OpenAI deployment and OpenAI API version. I have that tucked away as a config map that's already linked to the deployment, which the automated deployment kind of took care of for me. So that's already there. So all I'm missing is really the endpoint, right? And so now I think the critical part here is it's using workload identity, no API keys, passwordless authentication. So my app has an identity in Microsoft Entra ID. It can go out to Microsoft Entra ID, do the authentication, authorization, and now I have access to my Azure OpenAI service. So what we can do is, let's do this. Hopefully this is done. I will refresh. Okay, it looks like it's done. And remember this part right here. So now I'm at the point where I need to update my deployment, and I need to put the service account in, put the secret in, put the config map in. I also have to annotate the deployment, which gets a little tricky. So what I can do is basically, if I go back to my Azure portal, come over here, check the checkbox next to the service connector, go to YAML snippet, Kubernetes workload, and then I can pick my workload and check this out.
Is this the deployment spec of the application that we're running?
This is the exact deployment, yes. So this is basically like me running kubectl get deploy output YAML, right? So exactly the same thing. So, and because the service connector is in the same namespace, that's how the Contoso Air deployment got picked up in this dropdown. So yeah, so that's important. If you create a service connector in the wrong namespace, you're not gonna find this. So, but check this out. All the stuff highlighted in yellow. This thing gives me all the clues I need to actually configure my deployment manifest in order for me to configure the AI integration. So what I could do is I can literally just click apply right here, and it'll put that into my pod. So now if I do this, boom, 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 you can see my pods are all deployed. So 5 seconds, 4 seconds. Okay.
Yeah.
Now
we restarted because of the change.
Yeah. So let's go check this out. Moment of truth. Okay, come on. Boom, 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 boom. All right. So let's see. I'm going to ask it a question. So it's a travel assistant. I could say, hey, I'm going to KubeCon. How's the weather in Atlanta in November? Stinking. That's better. No errors. Haha. Look at that. So
nice.
Yeah. So now we can see just how easy it is to basically configure our applications, do the AI engineering, focus on AI engineering, and just kind of like leave all the infrastructure configuration, the maintenance and all that stuff to the AKS team, because they do it best. And then we can focus on writing our applications and hosting it on AKS.
That's amazing, Paul. Yeah, that was easy.
Cool. So that's all the demos that we have for today. We are just barely scraping the surface of this stuff. There's so much more that you can do with AKS and AKS Automatic. There will be links towards the end of the session today, but we highly recommend that you head on over to the AKS Labs website. We have 2 different labs on AKS Automatic where you'll learn all about it, from application deployments to securing it to all this stuff that we just demonstrated here. So I think that's all the time we have for today. So thanks, Ahmed. This has been fun.
Just remember, please commit those changes to the GitHub repo.
Yes, because I applied them live on the cluster, didn't I? Okay, yeah. I'll put them in right now.
Thanks, Paul.
Thank you.
Well, hopefully Paul is able to get those changes committed. Now we've had a lot of content today. We've gone through, we started with looking at the landscape of cloud native and AI development with Priyanka, had Brendan tell us a little bit about why Kubernetes is the ideal platform for your modern applications. Then we chatted, I got the chance to chat with Brendan and Sean and Amanda around the philosophy of how we've built AKS Automatic. We've heard from some customers. We've also got to do a deep dive with George, and now this awesome demo set with Paul and Ahmed. So what's left? Other than perhaps a snack. You're probably wondering now how you can get started with AKS Automatic. And so we have a few resources lined up for you here, as well as an exciting announcement. So first off, the easiest way to get started with AKS Automatic is by using the quick start. So go to aka.ms/goautomatic or scan this QR code, and it will take you to our quick start guide that will enable you to effortlessly deploy your first AKS Automatic cluster. I'll give folks a second to scan that QR code. Now, the other thing that Paul also mentioned is our AKS Labs site. If you're not familiar, we've done a series on Reactor previously, doing live labs, pulling from these AKS Labs, but we have a wonderful AKS Lab sites that has labs on all sorts of subjects to help you really get hands-on with AKS Standard and also AKS Automatic. There is an AKS Automatic specific workshop that'll help you get up and going. We'll also be featuring the AKS Automatic Lab at the upcoming KubeCon North America pre-day event. So please head over onto aka.ms/AKS/labs and check those out. We also have a really active AKS community. So if you're someone who wants to dive in deep to the docs, please head on over to the Automatic Docs. We also have the AKS community channel on YouTube. Some folks may have been watching this stream through that channel. Love to have you there. We also run a monthly AKS community call. We actually have our September one running tomorrow morning in the North America and EMEA time zone, and we host an APAC time zone call as well. So head on over to aka.ms/AKS/community calls to get involved in there and be able to have a more direct conversation with our product experts and get the latest news on what's happening with AKS and AKS Automatic every month. So we're really excited to announce that we will be running an AKS Automatic Hackathon starting in October. And this will line up really nicely with our presence at KubeCon North America in Atlanta, happening from November 11th to 13th this year. So why participate? We're running this hackathon in an open-ended asynchronous format to allow you to build at your own pace and really dive into all of the features of AKS Automatic. We want to see how you will solve real-world problems using AKS Automatic as your foundation. As Priyanka mentioned in her keynote, the platform is a critical piece to scaling out modern applications, and we want to know, what will AKS Automatic enable you to do? You'll have access to technical resources, mentorship, community support, and we'll have a great set of prizes that will be lined up for you, such as KubeCon tickets, swag, and showcase opportunities at Microsoft events. A little birdie even told me that Brendan has volunteered to provide a mentorship hour for the winning team. So some key dates. We will be kicking this off here on Microsoft Reactor on October 14th. The build phase will last 1 to 3 weeks, and then submissions and demos will be in week 4, and we will be announcing winners live from the show floor at KubeCon North America in Atlanta. If you're interested and ready to innovate, whether you're catching this on the live stream or you're catching the on-demand version of this, we would love to see you at our kickoff call. We have a session for North American and EMEA time zones, as well as for Asia Pacific time zones as well. And I'm going to leave folks with, what will you build with AKS Automatic? And that is it for me today, as well as our team. Thank you so much for joining us. We hope to see all of the things that you're going to do with AKS Automatic and to see you on some of our community interaction points. And I'm going to hand it over to Anna to wrap things up from the Reactor side.